For 8.6, we're going to spend 2 days on this section. We're going to be solving exponential equations. Really what we're going to focus on is what I'm highlighting right now. If we have an equation where a base raised to the u power is equal to the base raised to the v power, then those two exponents must be equal. So what we'll do immediately, just jumping right in here, take a look at example 1. We have 10 to the 3x plus 5 equals 10 to the x minus 3. Well, 10 to a power equals 10 to a power. That means that these two powers must in fact be equal to each other. And we can now solve this equation. We can minus an x from both sides. 3x minus x is a 2x. We'll have 2x plus 5 is equal to negative 3. We can minus a 5 from both sides. We will have 2x is equal to negative 8. Divide by 2. Very quickly we will see that x is equal to negative 4. So we can do that pretty quickly. When you take a look at number 3, you're going to notice that this is actually a little bit different. You have 3 raised to a power is equal to 27 raised to a power. Well, perfectly honest with you, we can't set the powers equal right now because our bases are different. However, what we can do is notice that 27 is 3 to the third. This right side here can be written as 3 to a power. So powers to powers are more powerful, as we like to say. 3 times x, we'll get 3 to the 3x power. Here we have 3 to the 2x minus 1. And what we do now is go back to what we did up above. The only way this equation is true is if these exponents themselves are equal. So I have 2x minus 1 is equal to 3x. I can very quickly subtract a 2x from both sides, very quickly seeing negative 1 is equal to x, or x is negative 1. Let's take a look at number 3, however. The big problem with number 3 is that 8 on the right side, of course, is a different base than the 4. But unlike our previous problem, 8 is not a power of 4. 4 you're not going to raise to the first, second, third power and get 8. 4 to the second power is not 8, it's 16. So at first glance, it doesn't seem like we're able to do very much at all. However, 4 itself is really 2 squared. And 8 actually is a power of 2 as well. It's 2 to the third. You must have the same base to be able to use that property of setting the powers equal. So powers to powers, we're going to multiply 2 times 2x is 4x. 2 times negative 1 is just negative 2. Here, 3 times 3x is a 9x. Well, using this property, we can set the power of 4x minus 2, set that equal to 9x. We can subtract a 4x from both sides, and very quickly see negative 2 is equal to 5x. Divide both sides by 5, and we have a fraction, and it's a negative number at that, but we're not concerned about that. That's perfectly okay. Let's go to the other page. And we're going to see, sadly, there are problems that you cannot change the one side into the same base as the other. Look at 5 and 8. 8 is not a power of 5. You cannot write 5 and 8 as, like we did in our previous problems, different powers of a different number. So just reading this, when both sides cannot be rewritten, we have to use logarithms on both sides of the equation in order to solve. So you know what we'll do? We could take perhaps a natural log if you'd like. We very well could also have taken a base 10 log. That would be fine. But you see, we have a property of logs. It's such a wonderful property. Look at this. We can drop down an exponent out in front as a coefficient. And then we have our x. X times natural log of 5 equals natural log of 8. Let's divide both sides by the natural log of 5. And let's just say that we want to answer to the nearest hundredth to 2 decimal place accuracy. We're going to use a calculator here. And just pulling the calculator out, we would just have to type in natural log of 8, close your parentheses, divide by natural log of 5. Very quickly you'll get 1.29. So 1.29 would be our solution. Let's take a look at number 5, very similar problem. Again, 3 and 4 are different bases. So I'm going to take a natural log of both sides, an ln. That will allow me to take my 2x and bring it down in front. Well, at this point, how about we divide by the natural log of 3? And we'd get 2x on this left side, but on the right we've got natural log of 4 divided by natural log of 3. We could type this out real fast. Remember your parentheses. And you'd see it's about 1.26 and a little bit extra. I'll say dot, dot, dot. Well, we don't have x by itself. We have to get rid of the 2 also. Let's divide by 2. And bring our calculator right back up and say, you know what? Also, let's divide it by 2. You'll get about 0.63. Okay, we've just got more of the same right here for number 6. Going to the nearest hundredth once again, this is slightly more complicated. Obviously 4 and 25 do not have the same base. So I'm going to take a natural log on both sides. I also put parentheses around the 2x minus 1 deliberately because all of this is coming down to be multiplied out in front of the natural log of 4. Well, tell you what, let's move on and get rid of this natural log of 4 from both sides. And we're going to need our calculator. We're going to have a 2x minus 1 on this left. But let's get some help from the calculator here. Natural log of 25, parentheses, divided by natural log of 4. And what do we get? About 2.32 and some extra. I'll tell you what, let's add a 1 to both sides. And of course you might guess we'd get 3.32. By the way, on the calculator you can just very simply say, hey, plus 1, add 1 to it. Well, you might guess the next step is to divide by 2. Indeed it is. Divide by 2, you'd get 1.66. So that's what we do to wrap this problem up. One final one, more of the same. Obviously 1.06 and 1.5, they're not the same base at all. So let's very quickly just take a natural log on both sides. We can bring our x down. And this is even less work. All we have to do is just divide by the natural log of 1.06. Very, very quickly, we'll see that we will get natural log of 1.5. Oops, I hit power instead. We'll have to delete that. Here, let's delete that out. Divide by natural log of 1.06. And hey, look at that. We will get 6.96. And we are done. So we're almost done with Chapter 8. Hope it's going well for you. Best of luck.